So today we're talking about the remainder and factor theorem, right? And it's just what it says. It's about remainders and it's about factors. And just a reminder, a factor is the number, are the smaller numbers. So you have the factors of 10. It is those numbers that are smaller than 10, but that would multiply to make 10. For example, 2 times 5, these are the factors of 10. And notice, if I wanted to, I have the 2 factors of the multiple. The multiples are the ones that are bigger, right? When we are really dealing with the multiples, we're dealing with the factors. I have the number that's bigger, 10. And if I divide it by one of the factors, I am supposed to get another factor, right? So that is if 2 is a factor, right? So if 2 is a factor, right? So 10 divided by 2 equals 5. So notice, if 2 is a factor, then 5 is also a factor, and notice there would be no remainder. Notice that. But if I had 11 divided by 2, what I'll get? I'll get 5, right? 5 2s are 10, and I'll have 1 remainder. And I put in that 1 remainder over that divisor that I was dividing by. The thing that I was dividing by, right? It might seem elementary, but this is exactly what we're going to be doing today. So if you understand this process, notice here, 2 is not a factor of 11. Therefore, we have a remainder. And so what we're going to be doing is we're going to be doing this. This is all we're going to be doing. This. But we're going to be doing it with equations. We're going to be dividing equations, finding the factor, and seeing if there is a remainder for the equations, right? So anybody still writing this? How we're going to do this is we're going to do this using long division. So we had to remember our long division, right? If the divisor is the thing that is doing the dividing. Think about it like the terminator, right? The terminator does do the terminating, right? So you have the dividend. That is the thing that is being divided. And then it is being divided by the divisor. Right? So you're seeing here 10, the dividend, is being divided by 2. Yeah? And of course, 2 is a factor of 10. So we have to say, well, all right, 5 times 2, that'll give us the closest number, which is 10. And then we go 10 minus 10, and we get a remainder of 0. If we get a remainder of 0, then 2 is a factor of 10. In this case here, you could see that we divided 11 divided by 2. Well, the closest thing we could get is 5 2s are 10 minus, and when we minus, we ended up getting 1 as a remainder. So therefore, the remainder is 1. Therefore, 2 is not a factor of this is supposed to be 11. So 2 is not a factor of 11, right? Notice the answer. The answer is the closest factor that we got, which was 5, which is not really a factor of 11. That's just the closest one we get. And the remainder of 1 over the divisor, the thing that is being divided. these are really important things to understand. We are not doing anything more than this. This is all we do. I'll give you 30 seconds. Sydney, this sound like if I torture in She-Boy. Well, now we're gonna get started with the real thing here. 2 multiply by 5. Well, that will give me 10. And so if I take the 10 and I was to divide it by the 2, I'm supposed to get back the 5. Yeah? And we know from the distributive law that we could take these 2 and multiply them. So if we take these 2 expressions and we multiply these 2 expressions, these will be the factors and this will be the multiple. And so therefore, if I was to take this multiple and divide it back by one of the factors, I am supposed to get the other factor. So how do we actually do that? Right? So you could just make a note here that these are the factors and this is the multiple. And so if I was to take the multiple and divide it by one of the factors, I'm supposed to get the other factor. And so we're actually going to see how to do this. And how to do this is long division. We actually have to long division this thing. Let me just see something, right? Yep, and I'm doing it there. So we'll just do it. Anybody have any questions? So let's just see exactly what we'll end up with, right? If I was to have x squared minus x minus 6, and I divide it by, oh crap, that's really poorly written. I divide it by x plus 2. So let's see exactly how we go about doing this. So the first thing that I would need to notice is the highest power is this square over here. And so in order to get that square, I will need to multiply this x by some other x. Right, so you look at the highest power. If this was a cube, then I would be multiplying by x squared in order to get the cube. So we look at the first term first, which is usually the highest power, because remember, with polynomials, we usually write them in descending powers. Right? And so the first term is usually the highest power. So x times x, well, remember, we have a minus sign here. X times x will be x squared. And then x times, and you'll see this is where the directed numbers come in. X times plus 2 will be plus 2x. And this is where the directed numbers are going to come in now. Right? So we see in here, we might have to come in the working column in case you're getting confused. This is x squared minus x squared. So x squared minus x squared, that is 0. So the x squareds are gone. And my internet is unstable, so please let me know if I start a cutoff. Sarah, you're hearing me clearly, right?
So you just stick.
I'm sticking a bit. All right, here what? Let me just take a second and check my Wi-Fi. Here what? I'm just gonna switch Wi-Fi. I might cut off for a minute just now. Sarah?
Yes, sir.
All right, you hear me clearly now?
Yes, sir.
Do me a favor. If I ever start sticking, let me know, right? So you can see that we started off with x times x is x squared, and then x times plus 2 is plus 2x, and now we do the subtraction. So x squared minus x squared, well, that gone to 0. But then look at what I have. I have, remember, the associative law. So this is minus x minus x, and then I have this minus sign here, minus, and then I have this plus 2x. Well, that gives me minus x minus 2x, because you know this plus don't matter anymore, which gives me minus 3x. So now I ended up having minus 3x here. So be real careful. This is where this gets tricky, right? And then this minus 6 doesn't have anything to minus, so it just remains as minus 6. We just bring it down. So now we look at the highest power and we see that it's 3x. So what do we need to multiply? It's not just 3x, it's minus 3x. So we need to multiply by minus 3. So now we go minus 3 on top here. Minus 3 multiplied by x will give me minus 3x. Right? And then, oh, by the way, it have this minus sign over here. Right? And then minus 3 multiplied by plus 2. 3 2s are, they'll get minus 6. And this is where the directed numbers come in. So you can see why I spent the first couple of classes on directed numbers and polynomials and such. Right? Because this will work out to be minus 3x minus minus 3x. And you see how things could get tricky here. Right? So you can see how you had to be careful. Minus 3x plus 3x is 0. So minus 3x plus 3x is 0. Minus 6 plus 6, you know, we ended up with minus 6 minus minus 6, which is minus 6 plus 6, which is 0. So 0, no remainder. So having no remainder means, try to do better, no remainder implies that x plus 2 and x minus 3 are both factors of the multiple x squared minus x minus 6. Sarah, you understand?
Yes, sir.
You don't find this cool?
Yes, sir.
Am I the only one here that find this cool? Sydney, you don't find this cool? No? Kinda. Denise, you don't find this cool?
Yes, sir.
All that just to get an answer 0. Maths is also. Well, you want 0, eh? Because you want to know if this thing is a factor. And when we do quadratics, you're going to see why that's important. Why it is we want to know about the factors of one of these things. This here is a quadratic equation. And we will talk in the next class about that, right? So anybody still writing this? Any questions? Well, now is your turn to do some. I have a challenging one for you here. Take x squared minus y squared and divide it by x plus y. Is x plus y a factor of x squared minus y squared? Take a minute, do it.
Yeah, I do.
You get through with it?
I guess it's like a factor of x.
First of all, is it a factor? Did you get a remainder of 0?
Yeah.
Yes. All right. So if it is a factor and you got a remainder of 0, what did you get as the other factor on top here?
If you're supposed to get a 0 at the end when you finish, take away everything else.
Yes. I don't know. Are you? If this is a factor, then you would get 0 at the end, right? So I want to know if it's a factor or not.
No.
No. So you didn't get a 0 at the end. So what did you get on top here then when you do it out?
Yeah, it's a factor, and on top is x minus y.
Yep. Very good. Right. So you'll see that the first thing we want to get rid of is this x squared here. So in order to get rid of x squared, I'll put x on top here. So that x times x will give me x squared. Of course, there's a big minus sign here. And then x times plus y will give me plus xy. So now I do the minus. X squared minus x squared. Well, that's gone. That's 0. Right? And in my working column here, I'll have minus y squared, but I don't have any other y squared to minus that with. So that means that I'll bring down that minus y squared here. Right? And then I have this plus xy. I don't have anything to minus it from, but it does have a minus sign in front of it. So that minus sign will make that plus xy a minus xy. So now, what I have to do is I have to get rid of this biggest value here, minus y squared. In order to get rid of minus y squared, I'll put minus y on top of here. And of course, you have a big minus sign over here. So minus y times plus y. I'll do the y's first. Minus y times plus y gives me minus y squared. And then minus y times x will give me minus xy. So you could see here, and if you look in the working column, minus y squared minus y squared will give me minus y squared plus y squared, which is 0. So the y squareds turn out to be 0, and of course minus xy minus xy is minus xy plus xy, so it does work out to be 0. And this is the factor. You understand, Sydney?
Yes, sir.
All right. Please note, just now, and you should know a difference of 2 squares is something that you have to know from CSEC math. And a difference of 2 squares is if you have anything that are squares, and we will do some difference of 2 squares exercises in this class today, so you'll get a little bit of a workout. But if you have one number squared minus another number squared, you could automatically factorize it as being that. This is a difference of 2 squares. And as an example, I'll give you 2 examples of a difference of 2 squares, right? Let's say if you have x squared minus 16, and they tell you to factorize that. You are supposed to recognize that this is really x squared minus 4 squared. And so you have a difference of 2 squares. And so therefore you could factorize it. You have the x and the y there. So you could factorize it as x plus y. Well, not x plus y. In this case, is x plus 4 and x minus 4. This is the difference of 2 squares. So this rule here is a rule that you're supposed to know. I think we covered it last time, and I can't remember. But we will cover it in this class.
Yes, sir.
Right. So this is a formula that you just have to know. Sydney, did you understand the division of this thing? Where did you went wrong? I was just curious.
Yes. At the end, when you could do the x, y over there.
Mm-hmm. And you're wondering where this come from.
Yeah.
All right, but you see, just worry about the first thing that's in front of you. So you see, when I started the question, I was just worrying about this x squared alone. I didn't really care about anything else. And so I fashioned my answer to get rid of that first thing, x squared, right? And then I do the minus, and then when I end up with this now, I just worry about the first thing here. How do I get rid of that? And if I get rid of that by that, well, then everything else will just work out. You understand?
Yeah.
All right, nice. So we go talk this talk after, but I think that you guys just need some practice with this. So using long division, I have a couple. I have divide using long division. We have 3 questions here. So let me see if we could do all 3. So 3 questions. This is just some practice with long division. You all want me to do the first one, or are you good to go? All right, well, here what? I'm going to leave you guys to do this, and please say done it when you're done. The quicker you done it is the quicker we go home, right? So we want to know, is this, first of all, a factor? So is it a factor? And if it is a factor, then what is the other factor that you'll get when you divide it? I feel I should do one, you know. Let me do this first one. Right? Just for people like Sydney who are a little bit iffy on it, I'll just do this first one. X cubed plus 6x squared minus x minus 30 is being divided by x minus 2. All right, and check the method here, Sydney, is I looking at this first term here, and I just want to get rid of that first term first, right? So I'll say, well, all right, how to get rid of an x cubed? Well, I have x multiplied by x squared on top here, and that's gonna help me get rid of that. So x squared times x will give me, and I have this big minus sign here, x cubed. And then x squared times minus 2 will give me minus 2x squared. And now I do my thing, x cubed minus x cubed, that gone to 0. I have in my working column here 6x squared minus 2x squared. So that is 6x squared plus 2x squared. Yeah, this is where you had to be careful. Yeah, so we can see here that we have 8x squared. 8x squared here, right? And then, well, nothing else to minus, so I just bring that stuff down. Now I'll look at the biggest thing that I have here, 8x squared. I want to get rid of that. So I'll go with plus 8x. Right. And let me see, I have a big minus sign here. So 8x times x will give me 8x squared. Then 8x times minus 2 will give me minus 8 2s are 16, so 16x. So I see my 8x's are gone. I'll have here what? Minus x minus 16x. So that gives me minus x plus 16x, which is, if the signs are different, you find the difference and keep the sign of the larger number, which is the 16. So it'll be plus 15x here. Right? And I bring down the minus 30. And now I'm just looking to get rid of this big guy here. So I will put a plus 15. And plus 15 times x will give me, I have the big minus sign here. So plus 15 times x will give me a plus 15x. And then 15 times minus 2 will give me minus 30. And you can see what's going on here, that you will get 0. Right? Minus 30 minus 30 is minus 30 plus 30. Minus 30 minus 30 is minus 30 plus 30, right, which is 0. And so we could see here that the factors in this case I wouldn't put the factors of, I'll put the factors are x minus 2 is a factor because I got a remainder of 0. And then the next factor is x squared plus 8x plus 15. That is the other factor. How you feel about it? You okay?
Yes, sir.
Denicia, how you feel about it?
Good, sir.
All right. Well, I'll have 2 more to do for me. And of course, I have a whole page of workout here for all you. But we ain't gonna, that gonna be for homework, right? So, yeah, you all have to do these 2. Type done it in the chat when you're done it, or say done it when you're done it. I'll be right here. You all will literally have just 5 minutes. Type done it when you're done it, right? I have x cubed plus 7x squared minus 6x minus 72 all being divided by x plus 6. Right, so what's the first thing I should have up?
X squared.
Alright, so if I get x squared, I have a minus here. So I'll have x cubed and plus 6x squared. When I do that minus, what am I going to get? 7 minus 6 is just 1x squared, and minus 6x minus 72. Then I will put a plus x. So x times x will give me x squared. And then I'll have plus 6x. And that will give me, these are gone, but minus 6x minus 6x is minus 12x minus 72. And of course I could go with a plus 12 here. No, I don't want a plus 12. I want to get rid of this, so I want a minus 12. Because remember, I have a big minus here. So if I put a plus 12, I'm going to end up getting, like, let me just say I put plus 12. Right, that's not the answer. But plus 12 will give me a plus 12x here, and well, minus 12 minus, minus 12x minus 12x will give me minus 24x, right? So I don't want that. So that is why I'll put minus 12 here. So now I'll have minus 12x here, and 6 12s are 72. So it'll be minus 72 here. And now minus 12x minus 12x will give me minus 12x plus 12x, which is 0. Right? So now this will make it 0. And this is my factor here. Denicia, did you get that?
Yeah.
Did you do this stuff?
Yeah.
That yellow sound very convincing, you know. Help me out with this one. X squared plus 3x minus 18 is being divided by x.
No, I don't do the first one.
Well, then help me out with this one. What should I multiply by first? What do I want to get rid of first? Joseph, the longer you take is the longer we take, right? If you don't know, you could just say you don't know. That's fine. What do I want to get rid of first? Huh?
Yes, I'm not really sure.
Wow, what I want to get rid of first is x squared, right? You understand?
Yeah.
So that's, you're always just looking at the first term. Just look at the first term. Forget about everything else. You want to get rid of the x squared. So I'll put x on top here because I know x times x is x squared, right? And I have a big minus sign there. You understand, Joseph?
Yeah.
All right. So x times x is x squared. And then x times minus 3 will be minus 3x. And now I do the subtract. X squared minus x squared is 0. I have a plus 3x minus 3x, which is 3x plus 3x, which is 6x. So I end up getting 6x here. You understand that, sir?
Yeah.
So you see how all of these rules with the signs, all of these rules are very important, right? And then, well, this minus 18 don't have anything to minus from, so I'll just bring it down. And now what I want to get rid of, you just look at the first term here. That is all. I want to get rid of 6x. So I know it's a minus here. 6 minus, if I could get a 6 here. So what will I do? I will put, if I put minus 2, it's 6x. So I had to put minus 6. I want to get rid of minus, I want to get rid of 6x is what I want to get rid of. So I'll put minus 6. So minus, no, I wouldn't put minus, will I? Yeah, I will.
It'll be plus.
It'll be plus? Let me see. Let me see if I get it right. Minus 6 times x is minus 6x. Yes, it will be plus. Because this will be 6 minus minus 6, which is 6 plus 6. So yes, it'll be plus here. So it'll be a plus here. 6 times x is 6x. So that'll be a plus here. And then 6 times minus 3 is minus 18. And so now I could see that 6x minus 6x will give me 0. Minus 18 minus minus 18 will give me 0. Joseph, you okay? You're gonna have some practice to do for the next class here, okay? Alright, so we have some practice. So we have some practice there for you to do with that. Now, here's what. All of these examples, we had no remainder. But what happens when we actually do have a remainder? X squared plus y squared divided by x plus y. So we know we want to get rid of x squared first. So I'll put x. X times x, big minus sign, is x squared. X times y is plus xy. Right? So that means that this gone to 0, and I'll have y squared from on top plus xy. So now I want to get rid of y squared. So I'll put a plus y. Right? Or should I put plus y? Because y times y will give me y squared. And y times x. Am I doing something wrong here? Y times y is y squared. Y times x.
Which is
yeah.
supposed to be minus xy.
Minus xy on top here?
No, sir, where the y squared be? Supposed to be y squared minus xy.
Oh, yes, that is true. Thank you. I know that something was off. But yeah, thanks a lot. So you see that y times x is plus xy. But the mistake that I made, sorry, is that this big minus sign here made it a minus xy. And that is the mistake that I made. So you'll see here that now I can have y times y will give me y squared, and y times x will give me plus xy. Y squared minus y squared is 0, and now I have 2xy over here, right? And so what this is, you know, because we can't go and add, we can't add anything again to get rid of that 2xy. We can't add anything again, right? Because what we gonna add? I'll make another mistake.
It would be negative y on top, and it would be y squared minus xy.
Negative y squared here?
No, negative y on top, and then the line with y squared.
It'll be y
So
squared.
when you have x plus y, it's supposed to be x minus y.
Alright, just not, okay. But why though? Because I put in plus y here, and y times y will give me y squared, right? because then I want to get rid of, so I want to get rid of y squared. You understand what I'm saying? Right? Right? So it makes sense, but don't worry. You'll see that in this example here, we did do the minus y and you got something else. So you'll see why. But in both cases, you can see that we get in a remainder. So we'll try both cases. So you can see that y times y is positive y squared. So y squared minus y squared will give me 0, right? And y times x will give me plus xy. So again, a remainder here of minus xy minus xy is minus 2xy. So, I'm sorry, my throat just catching my hair, right? In the example, you'll see that we did the x times x is x squared minus, and x times y is plus xy, right? And that is 0. What we'll have here is y squared minus xy. And so what will I do here is I put minus y. In the example, we had minus y, and you'll see you'll just get a different, you'll get a different remainder because it's like a different factor, right? And I had my big minus sign here. So y times minus y times y is minus y squared. Right? Minus y times plus y is minus y squared. And then minus y times x is minus xy. So you see, in this case, I was able to cancel the y squared, but I left with a remainder of minus 2xy, right? In this case, using a different factor, I was able to cancel the xy's, because minus xy minus xy is 0. But y squared minus y squared is y squared plus y squared, which is 2y squared. So in both cases, I ended up getting a remainder, right? So what happens with that remainder now? Let me take a look at this example, because this is the example on the chart. If I have 11 divided by 2, right? What will I have? I'll have 5. That is the factor that I get, right? This is the factor that I get on top here, plus the remainder, which is 1, which is under here, over the divisor, right? So in this case, and Shreya and Shreya and Sydney, I hope that the couple of times that Sarah corrected me here didn't confuse you all, right? I know I just whizzing it through. But in this case, look at what I have. It's the same thing. This is the multiple, x squared plus y squared. It's being divided by x plus y. What did I get? I got the factor of x minus y plus the remainder 2y squared all over the divisor x plus y. So this is what I'm talking about here, right? Notice how I have the 11. Notice I have 11 divided by 2. 11 divided by 2 is 5 plus the remainder over the divisor. So you see the first multiple, the 11, let's call that P of x. And P of x is being divided by G of x. So if P of x is being divided by G of x, we will end up, and these are just symbols that we are using to represent the functions. So this come like a formula then, right? This come like a formula, but don't worry, the formula will get easier. P of x divided by g of x. The answer will give us q of x plus the remainder r of x over the divisor g of x. 11 divided by 2 is equal to 5 plus the remainder over the same 2. What if I decide to take this 2 and fling it across the other side of the equation? What will end up happening? I'll end up have the 11 here is equal to this 5 plus 1 over 2 all multiplied by 2. So that means that the 11 is going to be, 2 times 5. So I have the 2 times the 5 here. And then 2 times a half, well, the 2's will cancel. And I'll just have the 1, which is the remainder. So 5 times 2 is 10. Plus 1, which is the remainder. So similarly, if I was to take this g of x and fling it across the other side, what will I end up getting? I'll end up getting p of x is equal to, I'll have the g of x being multiplied by the q of x. But the g of x will end up cancel with this g of x, so I'll just end up have the remainder here. The remainder alone. This is the formula that you'll need to just keep in mind for now. The dividend, which is the thing that was being divided in the first place, is equal to the divisor times the quotient. Right? The quotient is the answer that we got in terms of the 5, the factor there, plus the remainder. Right? So you can see here the divisor times the quotient plus the remainder. That will give me the dividend. Right, so similarly, when we just did this example here, and I'll only come up to here, so I hope everybody's seeing the full screen. When we did this example here, x squared plus y squared was being divided by x plus y. And what did we get? Well, in one of the examples, we got x minus y. Then we got this remainder plus 2y squared all over the divisor. If I take this and I throw it across, what will I end up getting? This is going to be multiplied by the quotient. So I'm going to have this x plus y multiplied by the quotient here. But it's going to cancel with this divisor here. So I'll just have the remainder here. So this is your dividend. This is the divisor times the quotient. And this is the remainder. I'll just let you all soak that in. Don't worry, it will get easier. The hardest part of today's class is over. It will get easier. Joseph, are you writing good notes?
Yeah.
Are you finished?
Yes, sir.
You finished writing here?
Yeah.
Denicia, you finished writing here? What does all of this have to do with anything? All right. Well, you can see here, I just put this here to show you guys the difference. How you have the difference of two squares here, and how the difference of two squares, you have the actual factors here. But in this case, this is not a difference. This is a summation of two squares. And a summation of two squares, these factors do not work because you end up get a remainder. Right? So you can't use this for a summation. When you add in two squares, you cannot use these factors. You can only use these factors for a difference of two squares, right? So we talked about this and we talked about this. Right, so we have, you can see that I do have a worksheet here, and this worksheet here does have answers here. Is these the answers for this worksheet? Yes, I do believe so. Something like that. But we're gonna see. We'll do a couple of examples and we'll see, right? Right. This is just, and these are the answers here. So you have questions and answers. This is just a exercise on completing the square. So I'll just do the first example. 9x squared minus 1. You have to be able to recognize when you have a difference, not completing, sorry, a difference of two squares. You had to be able to recognize that. So you had to be able to recognize that, A, 1 could be seen as 1 squared. You had to recognize that 9x squared could be seen as 3x all squared. That is 9x squared. And so you have the 3x and you have the 1, so you can factorize it as 3x plus 1, 3x minus 1. A difference of two squares. So we have questions here for you to practice with in terms of a difference of two squares, right? Now we look at the wonderful remainder theorem. We now reach the remainder theorem. P of x divided by g of x. And that gives me a quotient, a remainder over the divisor. What did we do? We took this divisor and we threw it across. And when we threw it across, what happened? We ended up having the divisor multiplied by the quotient here. And the divisor cancels with this divisor, so you ended up getting the remainder. Let me just say that the divisor g of x is actually an expression, ax minus b, a linear expression. Linear, you notice it has no square here. So remainder and factor theorem, what we dividing by will usually be linear. That means that the highest power is the power of 1. Right? So gx is equal to this. So I could take this now and put it in here. So you could see I have p of x is equal to, this is the g of x here, the divisor, multiplied by the quotient times the remainder. But I noticed something. This was somehow equal to 0. And you don't usually want your divisor to be 0. Because, you know, if this g of x was 0, then this entire thing will be p of x divided by 0. And that is undefined. Yeah? So we usually don't like the divisor to be 0. But in this case now, we don't actually have, you know, in this particular equation here, we don't actually have the divisor dividing anything. So we don't have to worry about that. If this was 0, then that would cancel out this entire thing. And I would just have p of x is equal to the remainder. How do I get this to be 0? Well, what I'll do is I'll come on this side and I'll say, well, you know what? I'm gonna put ax minus b is equal to 0. So that means what is x? X is actually going to be, I take the b and throw it across, so it'll be plus b, and I take the a and throw it across, so it'll be divided by a. So whatever numbers these turn out to be, you know, it could be 2x minus 3, for example. You'll have x to be 3 on 2. Yeah? And you'll see why the remainder theorem is so easy. If I was to take this x here, x is b over a, and substitute it inside of here now, right? So x is b over a. So the p of x will be the p of b over a. That is equal to ax. So x is b over a minus b. You notice the a's cancel here. And I will get b minus b alone, which is 0. And this whole thing gone. So what I'm seeing, what the remainder theorem states is that if I take the divisor, I put it equal to 0 and I get this fraction. If I put that fraction into the dividend, I will end up get the remainder. So we reach the easier part of it now, because this has, anybody still writing here? This has crazy implications. I have this and I want to know if these things are factors of this. So normally what would you do? You would go and do your long division and get 2 pages of work. But I don't have to do long division anymore. I could remember my remainder theorem, right? So if this here, let's try the first one, p of x divided by g of x. So in this case, g of x is x minus 1. Let's try this first one here. I want to know if x minus 1 is a factor of this, but I'm too lazy to go and do the entire long division. Oh God, wait now, my camera off. I'm too lazy to go and do the entire long division. So what I'll say is this, look back. I'll say, well, you know what? If g of x, this is g of x. I'll put in g of x to be 0. Therefore, x minus 1 is equal to 0. And so x is equal to 1. This is p of x. So what I am saying is that if I take x is equal to 1 and I put it in there, the answer that I get will be the remainder. If I get 0, well then there is no remainder and it is a factor. So let me see. Right? And I'll come on this side because I'm running out of space on this little white page here. So I'll write it over. Right? 4x cubed minus 5x squared plus 2x minus 3. And we want to find out, and we'll call this p of x. And we want to be dividing it by x minus 1. So we'll call this g of x. And instead of doing the long division, I know my remainder and factor theorem. Right? The remainder theorem says that if I take g of x and I put it equal to 0, then I could find what x is. X is equal to 1. Therefore, sub x is equal to 1 in p of x. So therefore, we will have the p of 1. The p of 1, remember, this is p of x. So I'll substitute in 1 every time I see x. So 4x, which is 1 cubed, minus 5x, which is 1 squared, plus 2x, which is 1, minus 3. So the p of 1 is 4 minus 5 plus 2 minus 3, and we can see the associative law rearing its ugly head here. Minus 5 is negative. Well, I could go 4 minus 3 is 1. I'm going to go 4 minus 5 is negative 1, and 2 minus 3 is negative 1. So did you guys get negative 2? That if I take the p of x, which is this big long thing, and I divide it by x minus 1, I will get a remainder of negative 2. So negative 2 is the remainder. Therefore, x minus 1 is not a factor. All right, so I'm going to leave it up to you guys to tell me, is this a factor or is this a factor? Remember, if I had done this entire thing and I had got 0 here, well, that means there is no remainder and g of x is a factor. So, you tell me, is x minus 2 a factor? So you take your g of x, you put it equal to 0. Therefore, x is equal to 2. Sub x equals 2 in p of x. Therefore, the p of 2 is going to be 4 times 2 cubed minus 5 times 2 squared plus 2 times 2 minus 3. 2 2s are 4 2s are 8. 4 8s are 32. I don't have my calculator on me. I'll leave my calculator in the next class.
Yes, sir.
As an add maths genius, I am an add maths genius, but I just fumble with my timetable sometimes. 5 4s are 20 plus 4 minus 3. So 32 minus 20 plus 4 minus 3 is equal to, what do you all get? Where you get, Sarah?
13.
13. Therefore, x minus 2 is not a factor of p of x. Because if I was to actually do the long division, I will end up getting a remainder of 13. 2x plus 3. That is my g of x. So can somebody tell me if 2x plus 3 is a factor?
Negative 99 over 4 minus 6.
Negative 99 over 4 minus 6.
Yeah.
Come now, man. You're using a calculator?
No, sir.
Oh, you're not using a calculator? Nah, man. It's negative 30 and 3/4 is what the answer is, right? Shreya, you got anything close to that? So therefore,
Yeah, I get that.
you get that?
Negative 30.75.
Yes, is not a factor. And remember, in maths, we do not like decimals. We prefer fractions. Don't ever give an answer in a decimal unless they ask you for it. Right? So it's not a factor. So we could see here, therefore, the remainder theorem states the remainder theorem states that if P of X is being divided by G of X, we say G of X equals 0, and that will give us X is equal to B over A. Right? The remainder theorem states that the remainder R is equal to, if you take this B over A and you put it in the P of X, P of B over A. This is the remainder theorem. You know, I don't want to do the whole divide thing because sometimes them polynomials could get real complicated. But I could just do this to find out if it's a factor. All right. So the factor theorem now. P of X is being divided by G of X, implying P of X being divided by this G of X, let me call it AX minus B, or AX plus B, right? Therefore, the remainder is equal to the P of B over A. This is the remainder theorem, right? So the remainder theorem is if you just take G of X to be 0, implies that X is going to be B over A. You take this B of A, you put it in the P of X, and you'll get the remainder. If that remainder is 0, then G of X is a factor. So this is the remainder and factor theorem. The remainder theorem says that instead of doing a set of big long division, you just, instead of doing a big set of long division, you just take your G of X and you make X equal to 0, make X the subject of the formula to get a value for X. You put that in the P of X and you will get the remainder. Why will you get the remainder? This is why. And remember, look at all of this. Look at this extensive mathematics, and where did this come from? This came from 11 divided by 2 is equal to 5 plus. This came from SCA level thinking. But we're taking the SCA level thinking and we are applying it to algebra. This is the remainder and factor theorem. Right? The remainder theorem, you take G of X, you find X, and you put that into P of X, and you will get the remainder. If the factor theorem is, if that remainder is equal to 0, then G of X is a factor. Right, it's time for we to finish. we literally just have these two here. But I want to do one, let's try one first. I'm looking for one with small powers. All right, you know what? Let me try number 5. I want to know if x plus 1 is a factor of this. And if it's not a factor, what is the remainder? The quicker you do this, the quicker we do. We go home, we're literally just going to do 2 questions again. This one and then this one.
No, you can mean.
He looking, yeah, he's a little meanie.
Because I now join back with my Wi-Fi one just now.
Oh, so you don't know what we're doing right now. 2x to the 4th plus 4x to the cubed minus x squared plus 9. And that is being divided by x plus 1. Is x plus 1 a factor? Can it even divide? Well, I'm not going to do the long division and find out because there's too much time. So what I will do is I will say let g of x equal x plus 1 equals 0. Let g of x equal 0. Therefore, x is going to be minus 1. Sub x is minus 1 in p of x. But where is p of x? So please state that this is p of x equals this. Yeah. So that means that p of minus 1 is going to be 2 minus 1 plus 4 minus 1 cube minus 1 squared plus 9. Notice the use of the brackets. So that'll actually give me, well, minus 1 to any even power is plus 1. So this is 2. Minus 1 to any odd power is minus 1. So this will be minus 4. This will be a plus 1 inside of here, but this minus will keep it a minus 1 over here, plus 9. So for 9, 10, 11 minus 4. Just now I'll do it. I'll use my calculator. Fine. Minus 1 plus 9 equals 6 is what I got. All right. Anybody got anything else? Sarah, did you get 6 as well?
Yes, sir.
All right. So therefore, x plus 1 is not a factor of p of x. Any questions? All right. So we have this very last one here. Now, this last question here, you know, all of the other questions, and yes, you do have to do these questions for homework. Remember, the next class next week, I might use that as the questions class. Remember, we had a whole bunch of questions from when we did polynomials, and we were supposed to correct it. You guys were supposed to do it for homework. We were supposed to correct it. Well, we added this on to it, right? So we have all of these questions here. And of course, you don't have to do all. Some of them have real plenty. I have some of these questions here. The completing this, sorry, not completing square, the difference of squares, right? And then you have these questions here where you actually have to do the long division. When you do the long division, you just end up getting some of these things here, right? And this is after the fact. You know, this is when we do it like this. You know, you end up get that. So you do, and of course you don't have to do all of the questions, but just try to do as much as you can, because remember, it's all about it's all about practice. Not only that, but in the next class, what we'll do is we'll spend the next class as a questions class, which means we will correct all of those outstanding questions. So all of these questions will be corrected in the next class, and as well as those polynomial questions from the last class as well. Right? So next class is all you're gonna have to shine, because you guys will have to be answering these questions. But this last one here is actually taken from a past paper. And this, when it comes to if it is that you get a remainder and factor theorem question in a past in your exam, chances are this is the remainder and factor theorem question you're going to get. So take a read on this and see if you could figure out what to do here. When that large polynomial, 6x cubed plus minus 11x squared plus kx plus 7. So when this is divided by this, the remainder is 3. Find the value of k. We'll take 3 minutes and see if you could do it and tell me what values for k you all get. 3 minutes, and then I'll correct it, and then we gone. So take 3 minutes. You have 3 minutes, and I want to hear the values of k.
So it's a
See the careless, easy mistakes anybody could make. But yes, those are the careless mistakes you have to look out for. Careless mistakes, no matter how smart you is, careless mistakes could attack anybody. So what they're telling you in this question is that when you actually do the divide, you divide this long thing by this, they're telling you that the remainder is... That means that when I do my remainder theorem, I am supposed to get the remainder of 3. So when I sub this into p of x, p of a half implies 6 by a half cube minus 11 by a half squared plus k by a half plus 7. That when I actually do this, I will end up get the remainder to be 3. I will actually get 3. That is what they're telling me here. That the remainder is 3. So when I do this, I will get 3. You see that k is the only unknown here. So we could find for k, right? So this will be 6 multiplied by 2 2s are 4, 2s are 8. So that is 1 over 8. minus 11 multiplied by 2 2s are 4, 1 over 4, plus, let's call that k over 2, plus 7 equals 3. So I have 6 over 8 minus 11 over 4 plus k over 2 is equal, let me throw the 7 across now, so we'll get 3 minus 7. 4, 3 minus 11 on 4. Plus k over 2 is equal to, signs are different, so that's negative 4. So 3 minus 11, so this is negative 8 on 4 plus k on 2 is equal to negative 4. Sorry, just let me know if I'm making any more careless mistakes. It seems to be my my trend today, recovering from my sickness, so my apologies, right? So negative 8 on 4 is negative 2 plus k on 2 is equal to negative 4. So throw over the negative 2, I'll get k on 2 is equal to negative 4 plus 2. So k on 2 is equal to negative 2, and therefore k is equal to negative 2 multiplied by 2. K is equal to negative 4. That's where you get, Sarah? Let me know if I do anything wrong.
Yes, sir.
Yeah?
I understand a little bit more now.
You understand what a little bit more? The question?
No, the whole weekend sign.
The whole word. So you didn't understand it from up here?
Yes, I did, but like the signs is confused more.
The signs. Which signs? You're talking about the question or you're talking about the topic?
When we actually doing it, like the signs itself in the weekend.
Yeah. So you see now why I spent the first 2 classes doing all of them, doing over them directed numbers and that kind of polynomial stuff and going over them rules, right? The signs in AdMath does rarely get to you. Right, Joseph, you understand this whole thing? Joseph?
I do.
Huh?
I do.
You do not.
No, I do.
Okay. All right. What do you think of AdMath so far? Because I specially requested you in this class because you if it is you want to get into anything to do with engineering or any kind of science at all, you need AdMaths, and you could see why you'll need AdMaths because it's a higher level of mathematical thinking, right? So I definitely requested that you be in this class simply because I think that it will challenge you a lot more than the CSEC maths. You know what I mean?
Yeah.
All right. So I hope you're liking it so far. All right, guys. Anybody have any questions? Okay, well then that is it for the remainder and factor theorem. Yeah. So we did the entire remainder and factor theorem in one class. So next class we will be doing just a questions class as well. And then the next topic we'll be working on will be quadratics. We'll do quadratics. We'll try to cut down quadratics in one class, but quadratics might take us 2 classes, right? So anyways, this is the classroom here. This is the first class has been added. The second class will be added later this week. And then the third class will also be added at the same time. Right? And that is the remainder and factor theorem. And then next class, I might just start quadratics in the next class, I might just start quadratics. I'm thinking about just leaving a video to answer all of those questions for all you. right? Because we want to get going with the rest of the curriculum. So next we'll have quadratics, and you can see it already have some videos in there. So feel free to check it out. That was the remainder and factor theorem. Welcome to AdMaths, everybody. I hope that you all having a good time. I love AdMaths, by the way. And that's it for today. I'll see you all next week.
Bye, sir.
Bye, sir. Have a good night.
You too.